Welcome to EconTalk, part of the Library of Economics and Liberty. I'm your host, Russ Roberts of Stanford University's Hoover Institution. Our website is econtalk.org, where you can subscribe, comment on this podcast, and find links and other information related to today's conversation. You'll also find our archives where you can listen to every episode we've ever done going back to 2006. Our email address is mail@econtalk.org. We'd love to hear from you. Today is November 6th, 2015, and my guest is Brian Nosek, professor of psychology at the University of Virginia and co-founder and executive director of the Center for Open Science. Brian, welcome back to EconTalk.
Thanks for having me back.
Now, you were a guest about 3 years ago. I think you had just started the Reproducibility Project, which was an attempt to reproduce results, and particularly starting in psychology. And the first results from that project have now been published. So I thought it'd be a great time to review that whole enterprise and have you back on to see what you found and where you're going in the future. I want to start, though, with some background. What does it mean for a result to be reproducible? Because there are different ways of thinking about it. So when you use the term reproducible in this in these ventures, what do you have in mind?
Yeah, it does mean multiple things. And the typical use of reproducibility is if you already have some data and a finding, can I, using the same data, obtain the same finding? And that could be as simple as taking the analysis code that you prepared and hitting run again in an environment that produces the same result. Or it could mean just taking the data and following the logic of what you did, generate my own way of analyzing the data and getting the same result. The way we use reproducibility is the further extension of that, which is to actually collect new data and see if we can obtain the same result. So this form of reproducibility is also called replication, but reproducibility is often used as an overarching term for these various ways of defining it.
Yeah, and what you really want to know is typically in psychology, for example, you're looking at an experimental result, and you want to know if you run the experiment on a different group of people but follow the same protocol, that is, ask the same questions or put the subjects through the same experiences, whether the result is the same. So to me, let me make sure I understand this because I'm a little confused. Replicate, what do you mean by replicate?
So in this context, replicate is the act of trying to create the same conditions that are necessary to observe that particular finding. And that's usually following the protocol very closely. But it might require some adaptations to that protocol that are perceived to be irrelevant to the finding, right? So if we did the original study in the United States and we want to do a replication in Germany, we might need to translate the materials for the participants to be able to read it. So it's not perfectly redundant, and no study is perfectly redundant with the original. There's always lots of changes, but the key is that those changes are deemed to be, understood to be irrelevant for what you're actually investigating.
So why would you, I'm going to say this in a negative way on purpose, why would you waste your time replicating all these results? We've already found them. What are some of the issues? We talked about this 3 years ago, but I want to review them. Yeah. Why would you be suspicious or concerned about some of the findings in the finest peer-reviewed journals in your field or mine?
Well, the general answer is that reproducibility is central to science, right? So a scientific claim doesn't gain credibility because of an authority saying, this is true, you have to believe it, or because that person has a good reputation. Scientific claims gain credibility by the ability for them to be independently reproduced. Someone else can follow the same procedure and find the same result. So the credibility is within the evidence itself, not within the generator of it. So that is a core principle of how scientific claims become credible, means that having reproducible research is a core value of what science does, how it operates, how we succeed in developing knowledge in science. So then well, yeah, great, that's a value. Why do we need to then actually redo experiments that have been shown in the literature? And the answer is because we don't know the rate of reproducibility of the published literature. We can assume that it's high, but we don't know that it's high. And there's a lot of indicators prior to this project being started that suggested that there were challenges to reproducibility, reasons to expect that it might be lower than we anticipate. And a lot of those boil down to the incentives that drive individual researchers' behavior. My success as a practicing researcher is contingent on me publishing, and me publishing as often as possible and in the most prestigious outlets possible. And what gets published isn't necessarily there are certain things that are more likely to get published than others. I'm more likely to get published if I get beautiful, clean, positive, innovative results, because those are the best kind of results. But not everything that we do in our research looks like that. In fact, most of it doesn't. And so my incentives are to try to make the research as beautiful and publishable as possible, not necessarily to make it as accurate as possible.
Well, that's what Photoshop is for. Oh, no, that's a different field. But so there's sort of two problems here. One is fraud, which is that there is an incentive, unfortunately, to literally cheat. But that's not the only problem.
Right. Right. The fraud is certainly a problem, and to go that distance, to actually deliberately deceive, is a big deal. But that is probably a very small part of the challenges for reproducibility, because most scientists aren't willing to go that far, even though the incentives are strong. But rather, most researchers are in it to learn something. They're trying to get to the truth. They're trying, why do all of this work if we weren't motivated by discovery and trying to find new knowledge and trying to apply that knowledge to solve human problems? So there's a lot of genuine effort that researchers are doing to try to discover true things, but we're also trying to survive and thrive as practicing researchers. And because of that, we have a conflict of interest. Right? The findings that I obtain have impact for my career outcomes. And so I will find reasons, not necessarily intentionally, to drop studies, to drop analyses, to analyze things multiple ways. I have flexibility in what ends up in the papers that I try to get published. And if that isn't a complete representation of how I got to those findings, then what's in the published literature could be more beautiful than what reality is.
So in the paper you wrote a while back that we talked about 3 years ago, there are two things I just want to mention again because they're so important. One is the line, published and true are not synonyms, which is hard for people to accept. I think journalists certainly have an incentive to ignore that truth, and so they publish lots of things that are published results in peer-reviewed journals because they're really interesting and people want to read about them. Whether they're true or not, it's a different question. But just quickly retell the research finding you had about shades of gray that was in that original paper.
Yeah. So Matt Motel were interested in a very fascinating area of research in psychology right now, which is how physical states and mental states may be linked in robust ways, in unexpected ways. And so we had some data where people had to judge gray swatches and rate how light or dark they were, match them with other gray swatches. And people do this task, and it's just a perception task. How light or dark is this? And when we analyzed the data, we separated the liberals and conservatives from the moderates. And what we observed is that moderates were better at perceiving shades of gray accurately than people that were on the far left or far right.
Physical shades of gray.
Physical shades of gray, right? So it sort of really plays into all that argument of you're a black and white thinker. You just
so
think that
beautiful.
It's right? It is wonderful.
By the way,
it is a wonderful result.
Brian, I tell the story all the time to people, and then when I tell them that result, they always go, "Yeah, wow, that's cool. That makes sense." So go ahead, but then what happened?
Yeah, so we could have just stopped there and sent it in for publication because it is an amazing result. result. It's beautiful. It's innovative. It would have been highly publishable. But we said, you know what? Let's do a sanity check here because this is kind of amazing. Let's go ahead and do it again. We had an easy mechanism for data collection, so we didn't have any barriers to running the study again. And so we did it again with a very large sample, and it would disappear. It didn't show up the second time. And then we said, oh, my God, why did we do that second study? This was the biggest mistake. Like, we had the finding. Now it's gone. And so we didn't end up publishing the paper. We ended up publishing a story about this, that result was exciting. But the first time we found it was more exploratory. We found a data set that was relevant. We looked at it in a few different ways, and we found this great result. The follow-up was a confirmatory test, right? We put some constraints on ourselves because we had a finding. We had a method that we used to find it. We had a way in which we analyzed the data to observe it. And now that we had those things, now we had constraints. And then we did the study again in the exact same way, and it went away.
Did you do it a third time?
We have not done it a third time, although Matt is talking about it.
Were you tempted?
Both of us sort of still feel like there's potential here.
Well, maybe the second study was the unrepresentative one. Or is it the case that once it doesn't get confirmed, it's not a reliable finding, period?
No, your first response is right, which is no one study is definitive, right? That first study was a good, interesting initial effect. The second study provides some skepticism. Both of them contribute to an understanding of, okay, well, maybe we're not sure here. And a third study would be useful. We didn't yet follow up on this, but I do think it is still a possible result. But it certainly isn't a publishable result yet. Given the current incentive structures in science, we need to have clear evidence. And so what would we do if we sent both of these studies to a journal? The reviewers will look at it and say, well, we don't know what to believe here. And so how can we possibly publish this? Whereas if we had just sent the first one, it would have been much more likely to be accepted if they didn't themselves demand a replication, which is very rare, at least historically. 3 years ago, it was extremely rare. Now it's more common to ask for a replication of such.
So just to add a little twist to your study, which I suspect you did not do, you might have, or maybe you did do it, you might have at the same time that you asked people to identify shades of gray and check their political views, you could have also checked their eyesight. You could have given them an eye test, a physical eye test, and graded their eyes' ability to see. And perhaps it might have turned out that some of the people with the less high-quality eyesight maybe ruined your data in that second test. So you guys said, we're going to let's exclude this group whose eyesight wasn't quite so good, and then it confirms the finding. And I think the challenge in economics, certainly, and I suspect it's also true in psychology, is the temptation to remove outliers, to censor the data, meaning to throw out high or low variables because obviously they're not representative, or certain types of people in the sample. I think I've mentioned this before on EconTalk, but the study that I once read that got front page coverage was on the relationship between drinking alcohol and various forms of cancer for women. And it just turned out that they had excluded women who didn't drink from the sample. Now, it turned out that women who didn't drink actually had higher rates of cancer than the women who drank a little bit. That kind of ruined their story. But they justified removing the women who didn't drink because, well, maybe they just started not drinking. But, of course, that would be true of all of the sample. So that's a very unattractive reason to me for excluding them. But the point is that usually, in many, many situations, we have lots of choices that take place in the kitchen. And if you're not in the kitchen with me, you don't know what I've done. And that's why your work, this project that you're doing is, I think, so incredibly important.
Yeah, that's a great example. And it really is the case that we have enormous opportunity, right? There's so substantial flexibility in how we analyze the data, right? So eyesight would have been a great one. We could have then thought, well, hang on a second. We had a lot of young people in this So maybe their political views aren't really yet well formed.
Fully
so
formed.
Just the more people that are older. Or let's look at their actual political knowledge, right? So it's really those that really understand these issues that this would happen, right? So we could have analyzed the second study to death and maybe found some moderating influences, right? Oh, it shows up here and not here. And then our finding is preserved. But of course, the problem is that we've now looked at the data, and the data itself has shaped how we analyze that data. So we're both simultaneously generating and testing the hypothesis with the same data. And that's a no-no, right? We can't do that. You cannot generate and test hypotheses with the same data confidently.
And yet,
so the key is we should do that, right? We should dig into that data in the second study because we have an idea, we have a hypothesis. So we do all that digging. If we find something like that, then we can't stop there. We have to test that with new data. And that's this cycle of science, right? Is no study is definitive. We are going to explore and learn from our data. And then we need to follow it up with real hypothesis tests where we put the constraints on ourselves.
And Ed Lemers pointed out in his famous paper, Let's Take the Con Out of Econometrics, and talked about on this program, that when you dig in the data like that, when you have a hypothesis and you test it, there's a standard set of statistical tests to test for significance. And if, however, you start going back and forth between the data and your hypotheses, trying different formulations, excluding certain sample points, adding variables, taking some out, you've really left, not really, you have left the field of classical statistical testing, and the tests don't apply anymore, but we pretend that they do.
Right. Yeah, exploratory analysis is very important, but it is also very different than what you can conclude from confirmatory tests.
Okay, so let's go on to the your project, the reproducibility project in psychology. What was the plan? What did you? What was the idea, and how did it come to be?
So, I guess it's about 4 years ago now. As we thought there's lots of discussion about reproducibility. We've thought about this for years, but we really have no direct empirical evidence about the rate of reproducibility in any field, let alone psychology, my home discipline. So how would we get some kind of estimate for whether there is a problem in reproducing published results? And the most plausible reason is you take a random sample, or the ideal way is to take a random sample of the published literature, run replications, and see how many replicate. And that seemed like, well, geez, that's going to be hard to do.
Yeah, that's a ludicrous idea. No one wants to do it.
No, it is ridiculously dumb.
There's no money in it. There's no fame in it. There's no glory.
Turns out all of those ideas are wrong because here I am talking to you.
The glory.
The glory, exactly. But we thought, okay, well, we can't do the perfect ideal to run a huge sample, but can we get close? What would it take to get close? We can't devote all of the resources in our own lab to do this, but there are a lot of people that are interested in this issue, and maybe we could get a group of people together to run 10, 15, 20, maybe 30 replications. And that would at least give us something, right? Somewhere to start, because we just need something to ground this discussion. There's lots of mudslinging, there's lots of hoo-haing, there's lots of arms waving about the reproducibility challenges or not challenges. We need some to ground that in some evidence. And so we just started to say, let's each contribute a little bit. Let's crowdsource this and have a common protocol for how we're going to select studies, how we're going to develop the replications themselves, how we're going to conduct that, how we're going to interact with the original authors, and then we'll write a paper with the aggregate results. And so no one person or team will have to spend too much of their resources on doing a replication, but collectively we'll get something interesting out of it. And so we started just by creating a web page, and this was at the same time that we built the Open Science Framework, which is our scholarly commons, a free open infrastructure for people to manage their research. And so it became the infrastructure for supporting the reproducibility project. And then we sent out an email and said, anybody want to join us? And very quickly, it was a team of 50 people. We said, oh my gosh, this actually might work. And then after a few months, it was a team of 100. And after a few more months, it was a team of 150. And so our aspirations of how much we could actually get done sort of grew in response to the fact that there was a real community of people in the field that were hungry to try to get some credit, some evidence, some understanding of whether this is a problem and to what extent it is and what we might do about it.
Now, were you worried that some of them were too hungry? It's kind of fun to tear down a famous study that your mentor's enemy did that ruined your mentor's research, So how'd you deal with that?
And certainly in replication, that has been the perception of why one would ever do a replication is as a hostile act, right? Replication is a threat, not a compliment in the present culture of science. Because why would you question my work is the immediate reaction, rather than what we would idealize as the response to replication, which is, oh, my finding is important enough that someone else wants to independently confirm it, right? That's should be how it is, but it isn't how it is. So there is that challenge, and there certainly is variation in people's priors of what they think the problem is and whether they think particular effects will replicate or not. So the way we tried to manage that in this process was to provide constraint on us as replication teams. And there are a variety of constraints, but a few of them are that we defined a sampling frame of a particular set of studies that were eligible for replication. And then we slowly made studies available from that set to minimize selection bias and to maximize just trying to have enough flexibility so that we can match studies with teams that had the relevant expertise, experience, resources. So what part of what that tried to do is minimize the likelihood that individual team members would say, oh, there is this particular study I don't like. Rather, they're just looking at these particular studies from this particular year, from this particular journal, and they don't have any strong stake in any of them, but they're just looking at them for which ones they can do effectively.
So you ended up... Go ahead, sorry.
Oh, so yeah, that was part of the constraint that we had to ourselves. A second element of the constraint on the replication teams was we required interaction with the original authors to really do the best job that we can to have a good faith replication. So trying to obtain the original materials from the original authors, getting their critique of the design before it went into production, and then documenting, if they continue to have concerns, documenting those and surfacing them. So that a reader can evaluate themselves. Was this a fair replication or not? Do I believe this one or not? And then the final part was just transparency of the entire process. So everything about the project, all of the materials, all of the data, all of the designs, the original protocol, all of that is available on the Open Science Framework so that others can dig into it and decide what they think. And then that includes commentaries from the original authors about the results. And those are attached right with the results if the original authors chose to write a commentary.
What's fantastic about this is that there was a study, replication attempt outside of your project. It was a very, very high-profile project, high-profile study that had shown that when hearing words related to the elderly or being a senior or being old, people had left an experiment more slowly than when they didn't get stimulated by those words. And when I saw that result, I was kind of skeptical about it, and I guess somebody else was. And they tried to replicate that finding, and they couldn't replicate it. And I remember the hostility that the original author gave back to the replicators because the author said, you didn't do it right, your tone of voice must have been wrong, you didn't pronounce senior correctly. There of course are always things you can point out that might have made it plausible that the replication would fail, even though the result was true. Yeah. And what's nice about what you've tried to do is that you've tried to make that process less of a debate and more of a catalog of what actually went on. So I think that's phenomenal. So let's talk about the universe. So you ended up of studies. You ended up with how did you well, not how did you, but what was the universe you ended up choosing for replication?
So we used 2008 as the year of publication. And then we selected 3 journals from that year: Psychological Science, JPSP, Journal of Personality and Social Psychology, and JEPLMC, Journal of Experimental Psychology, Learning, Memory, and Cognition. And then we started with the first article that was first article that was published in the first issue of the 2008 year, and we just moved forward from that initial article. And then there were a lot of studies in the sample as it accumulated that we couldn't feasibly do. This was a volunteerism project. This was built on minimal resources at first. We did get a grant later, but we did this just with people who were willing to put in some time. And so there were studies that were in this set that were longitudinal studies of 3,000 Dutch, and they measured them over 5 years. We could not put the resources in to do a replication of that. And so there is a selection bias in the sense that the studies that we were able to do from this frame are a subset of the total studies that we could have done. And there are reasons, most of them being feasibility constraints for ones that were included versus ones that were not.
And you ended up with 100 studies, correct?
100 completed studies in the report, yes. But more were claimed, but some of them didn't get finished.
So if I have just a technical question, if I have a study that had 5 findings, is that one replication or was it 5? How'd you decide what to replicate within a study, within a published article?
Yeah, so that's the one level now down deeper, is that once we identify the article, well, what's to be replicated? Some of these articles had 6 independent studies, and within each of those 6 studies might have had 10 or 12 findings that they report and talk about. So the selection process we had for that, just to have, some constraint for us so that we could focus on a particular thing with the implications for bounding our inference, is that we, by default, selected the last study so that we wouldn't have selection bias of looking at all of the studies and trying to pick which one we thought would be most or least, whatever, likely to replicate. So start with the last one, and then if it's not feasible.
What do you mean the last one?
So a paper will have studies presented in some order, and it, whatever the order is that the researchers decided to report those. And so just reading through the paper, this is number 1, that's number 2, that's number 3. Okay, we're going to start with number 3 and identify the key finding from that study. And so it's trying to narrow it down to a single test that occurred in that study. If it turned out that it was infeasible to replicate the 3rd study, but the 2nd study was feasible to replicate, then the team could move and do the 2nd study. Sometimes even the original authors recommended moving. But
by study, you don't mean paper. You mean...
That's right. So it's within a paper, there might be many studies.
Correct.
Yeah, so in psychology, this is common, where it's a very simple paradigm, and so they run 5 different experiments, all on the sort of a similar kind of question, and then write one paper about it.
Okay. So let's... so you ended up with... in 2008, there were an enormous number of articles written in all 3 of these journals, but you ended up with 100. Is that just out of because it's a nice round number? Why'd you get to 100?
So we got to 100 because we really, really wanted to get to 100. Is the actual answer.
It's like Thomas Jefferson. Thomas Jefferson died on July 4th, 1826. He wanted to get there.
Right, yeah. And so the original aspiration was 30, and then we thought once there's a lot of people involved, we thought maybe we can get to 50. And then once we got a grant from the Laura and John Arnold Foundation to help support the project, we aimed for 100. And, the more is better with data, right? We have more of these replications, then we can have more confidence in our inferences, more precision in our estimates. And so 100 has appeal just in its roundness, but it also was the target that we committed to our funders and to the team to say how much can we actually get done. And it was an enormous effort to get there. Mallory Kidwell and Johanna Cahoon, the two project coordinators, were just pushing to get us to that number. So
what were their names again?
Johanna Cahoon and Mallory Kidwell were the coordinators. And so we have charts on the wall in our office about progress on this. We have markers of which studies are we going to be able to get done, which teams are making progress, where are they, and we're just really pushing to get to that number.
So to get to 100, did you go past 2008? You did, right?
No, we didn't go past
2008.
Yeah, so there was 488, I think, total possible articles we could have selected from. I think it was 165 or so of those became eligible, so they were in the frame that could be selected from. And then of those, 113 were actually replications got started, and 100 of those got finished.
And you do realize, of course, that there was a financial crisis in 2008, so that kind of really throws out the whole. And it's also the year after the Red Sox won the World Series for the second time in this millennium. There's a lot of problems, but 2008, we'll stick with it. That you just, I assume you picked a year that was recent, but not too recent.
Yeah, we wanted something, so all of these are sort of decision factors, right? Because the ideal is a completely random sample, but a completely random sample of what? Where does psychology end and other disciplines begin? So that would have been too hard to define. And then there's also a lot of journals that are very low impact. And so we thought if we do a completely random sample, then we'd get a lot of studies where people would say, oh, but we don't take those studies very seriously. It's really the studies in the important outlets. So we constrained to journals. And then we constrained to 2008 because this started in 2011. But we really wanted to have recent enough where we could get the original materials, right? Failing to reproduce because we can't get the materials is one reason that is less interesting than potential other reasons. But at the time, we wanted it far enough back where we could get estimates of how much impact those were having. So we didn't pick the year that we started as the year because we thought, oh, we'll finish this in 6 to 9 months. And so we we need some time to go. Of course, it took 3.5 years, not 6 to 9 months.
So I'm going to read the abstract from the paper that you and the rest of the team published in Science recently, and then we're going to talk about the findings. So I'll read the summary, the abstract first. Reproducibility is a defining feature of science, but the extent to which it characterizes current research is unknown. We conducted replications of 100 experimental and correlational studies published in 3 psychology journals using high-powered designs and original materials when available. Replication effects were half the magnitude of original effects, representing a substantial decline. 97% of original studies had significant results. 36% of replications had significant results. 47% of original effect sizes were in the 95% confidence interval. The replication effect size, 39% of effects were subjectively rated to have replicated the original result. And if no bias in original results is assumed, combining an original and replication results left 68% with significant effects. Correlational tests suggest that replication success was better predicted by the strength of original evidence than by characteristics of the original and replication teams. End of quote. So I want to talk about 3 of these findings. The first is that the one that got the most press. 39% of effects were subjectively rated to have replicated the original result. And that number, 39%, got bandied around a lot in the news accounts of your study. Talk about what it means by, first of all, how did you measure success? How did you measure it replicated the original result? And why is the word subjectively in there?
Yeah. So that abstract summarizes 5 different ways of characterizing reproducibility. And this is important because there is not, it's what does it mean to have replicated the original result? It seems like an easy question, but when you start to unpack it, it's a very hard question to answer. And so we used multi-methods, right? We used 5 different ways to sort of look at what the relationship between the replication and the original results were. And one of those was generated the number 39%. And so the subjective ratings were the result of the replication team finishing the study, doing the analysis, looking at the results, and then deciding, when I look at this and I look at the original result, is the replication success or not? And they gave a yes, no answer. And so it was their subjective judgment of that. That one was very highly correlated with another one of the criteria, which is, was it a significant result? Did they obtain a p-value of less than 0.05 in the replication, like they did?
Stop there and explain what a p-value of 0.05, why that matters.
Yeah, so p-values are the standard in most areas of science that use inference testing for deciding about the credibility of a particular piece of evidence. And what a p-value means is assuming the hypothesis is true, how likely is it that we would observe this pattern of data? Assuming the null hypothesis, I should say, right, that there is no relationship to observe. How likely is it that we would observe these data? And when these data are extreme, they're quite different than what you would assume if there was no relationship. Then you get a low p-value. And so lower p-values are better in the sense that they're saying these data are unlikely to have occurred with no relationship. And so then people want to say, well, so then that means that maybe my alternative hypothesis that I think there is a relationship is true. And so p less than 0.05 is the de facto criterion in most scientific research for whether the effect is considered significant and that you can claim that there is evidence for your effect.
And it's important to point out that the word significant here in statistics is not the same as its use in everyday language. In everyday language, significant means important, effect, has a big effect, matters. It matters. Right. But in statistics, it just means that it's unlikely to be true by chance, which it still could be a significant finding statistically, but insignificant. So, a 20% increase in some variable could have a significant impact on another variable, but the change could be so small that it's not worth worrying about, or it's not something that you'd normally care about, but it could be statistically significant. So it's just important for listeners to keep that in mind who aren't used to these kind of words.
Yeah, and this came up in a big news story very recently about does bacon cause cancer? And, all of us bacon lovers were very concerned about this particular result being reported in the news about bacon being linked to cancer. And also there was some discussion about whether it was as strong as or stronger than smoking. Oh my gosh, how could that be? Well, it turns out it was a statistically significant result. It was unlikely to have occurred by chance, but the effect size was not very small, or it was not very large. And so this comparison, as you're talking about, the importance, how much it predicts, can be very small, even if it's measured highly reliably.
So we're putting that to the side because we're going to stick with statistical significance right now. But so going back, so let's go back to the 39% number. I interrupted you to clarify p-value. So people made an assessment of what?
Of whether they thought the replication was consistent. The finding in the replication was consistent with the original. So was it successful in reproducing that original result? And they just gave a yes/no answer.
But how did they make that call?
So they just by looking at the evidence, and the correlational data suggests that mostly they used the p-value to make that assessment, and might have been influenced to some degree by what they observed as the effect size. How strong a result was the original? How strong a result was the replication?
So the average finding, if I have this, let me get back to the summary. Right. So the average finding was half the size of the original.
Yeah.
So that means that some of them were less than half, I assume.
Yeah, quite a few.
Quite a few. Quite a bit less than half. They could still be statistically significant, though. So who made the call about whether that was a replication or not? So let's say you find some effect, it's claimed, you try to reproduce it, it's only a third as large, but it's still statistically significant. Is that a confirmation or is that a failure to reproduce?
Well, because we had 5 criteria, it's both. And because in some of those criteria, like the 36%, it would be the 36% of statistically significant results, it would count as a success. In the effect size comparison, it would look like much less of a success, although that's sort of continuous. It's not a discrete yes or no. It's a comparison of the effect sizes. And in the subjective assessment, it's whatever the replication team looking at it says, well, yeah, it's smaller, but they're showing the effect. We're showing the effect that they found. It's smaller, but it's still the same effect. So we say it's success.
So let me restate again one line, 2 lines from the summary, from the abstract. 97% of original studies had significant results, which is impressive for those other 3 that still got published. But 3%, but 97% had significant results. 36% of the replications had significant results. So that's about 39%, I assume, doing the math in my head. So that's the failure to find a significant result is overwhelmingly going to be the measure of whether it was a success or whether it was a successful reproduced result.
Yeah, those 2 criteria were the most strongly related to each other of the 5 different criteria we used to evaluate replication success.
So I want to step. So is 39% a high number or a low number? You know, it's interesting. Some would say that's appalling. Others would say, "Wow, 39%. Good for you. Good for psychology." It is something of a wake up call. I'm curious what kind of reaction you're getting, not from the authors. We'll talk about them in a minute, but from the field in general. When you've published this recent overview that summarizes the findings by saying, here's the way I would say it, about 60% of the studies failed to replicate, and about 40% seem to be held up, at least under this one test. What's the reaction of most people in psychology? Do they go, yeah, I always knew my field was a fraud, or did they say, wow, there's a lot more science here than I thought? Is the glass half empty or half full?
Yeah. My experience with the reaction to this paper so far has been that it operates as a Rorschach. So you get a lot of information about people's prior beliefs by how they evaluate the results of this paper. So people that have thought that there are challenges and problems look at this and say, see, and now we need to do all of these changes, and now we need to fix this, and now we need to do that. People who have not thought that there was a problem, thought that this whole discussion has been overblown, say, see, replicators are incompetent. And maybe it's somewhere in between. We don't know yet. But it is a paper that's serving the purpose of having done the research in the first place, which is to ground these debates, these priors, these different beliefs about the challenges into something where we can actually dig in and start to unpack it. So what's really great that's already happening is that all of these data are open, all of the methodology is open, and there are lots of people with very different prior beliefs about whether there's a problem or not that are digging into it, critiquing it, finding new things, finding things that suggest the problem is worse, finding things that suggest the problem isn't so bad based on these data. But it is a data-driven discussion. Now, they're hypothesis generating, right? This is exploratory at this point, looking at these data. But nonetheless, it's using data rather than just whatever people think based on their anecdotal experience.
So I got interested in this decline issue from an article that Jonah Lehrer published in the New Yorker. He's since Jonah's fallen on hard times, but it was an article about Jonathan Schooner, the psychologist who had found this provocative effect, counterintuitive effect, and then went back somewhat akin to your Shades of Gray study, and had and by the way, that's what you would have called your paper if it had been published, 50 Shades of Gray. It's a shame. Who knows? Maybe you'll resurrect it. But anyway, Jonathan Schooner. Schooler, excuse me. Jonathan Schooler found that when he went back to retest a result of his, that it got smaller, I think by about half. Then he went and retested again a few years later. It got smaller again. Yeah. And this came to be known as the decline effect. Do you have any thoughts on that? And especially given that you've found it now in this paper, why should we observe a decline? It's hard to imagine that somehow over the last X years people aren't as good at Y or Z, whatever is being tested, that the effect is somehow diminished by sunspots or whatever. It's alarming.
Yeah. So we don't know what the answer is, but the most available explanation, meaning the one that just sort of drops right out of this whole debate about reproducibility, is that the decline effect is a function of the publication bias. This sieve of what gets through from actual research being done to research being published requires statistical significance, right? Getting that p-value below 0.05, but is also done in a context where research is pervasively underpowered. We don't collect enough data for testing the questions and the effect magnitudes that we can expect in the kinds of research that we do. This is a pervasive problem that's been discussed since the 1960s. But the consequence of those two things happening simultaneously, low-powered research and requirement for statistical significance, means that the only way you can get statistical significance is to take advantage of chance and happen to observe larger than what are real effects. That just because I run 5 studies, I am investigating a true effect. One of those will happen to be larger than it really is and obtain that statistical significance, and that's the one that gets published. So if that is occurring at a pervasive scale, then the results of the reproducibility project are exactly what you would expect as a consequence, which is most research is actually, when you just do it and report it, regardless of whether it's significant or not, is going to estimate smaller effects than those few that get through the publication pipeline. Now, I'll say that that's not necessarily the only explanation, because there's other ways that we could understand the decline effect, and there's lots of reasonable hypotheses, and many of them can be contributed. For example, we could have observed smaller effects in the replications because the replications were not tuned to the particulars of the sample and setting in which they were conducted, like the original research was, right? So it's possible that those original authors design their study in such a way that it would obtain the largest possible effect they could in that original setting. And then when the replication team did it in a new setting, they didn't change it enough or tune it enough so that you would get that strong of an effect, because there's other factors that were influencing the result.
Tuned in ways that aren't observable or that aren't listed in the protocol.
Yeah, or that you wouldn't know that you needed to change. That are subtleties, right? What kind of language you use to communicate to those kinds of participants.
Facial expressions. My favorite example of this is I may have mentioned this before on the program, but it's so good. I should use it at least once a year, which is the studies that showed that that people have ESP. They have extrasensory perception. And there was a test done with cards. So I'd put a card down on the table and I'd say, guess what suit this is? And people would guess. And then some people were shown to have a much higher than 25% ability to identify the suit. But it turned out that what had happened was, in doing the experiment, the people who had done the experiment would do a practice. So I'd say, guess what suit? I want to get you ready for the experiment. Guess what suit this is? A heart. Oh, you got that one right. How about this next one? A club. Oh, that's 2. You're 2 for 2. That's great. Well, let's keep going. Whereas if they didn't get the first few right, they'd say, okay, now we'll start. So once you do that, you've kind of, and if you didn't write that down or you didn't have a video camera, you couldn't reproduce the finding that people have extrasensory perception. You'd find they didn't. Anyway, I want to ask a question that's not in the science paper, in the summary of the results. Obviously, what you did is I think it's incredibly important and really, it's glorious even if you don't get any glory. And I think you do get some glory, so I'm very happy for you. But
I have been, but the 269 others have not been their share of glory. So I am benefiting from all of their work in actually getting this done.
Well, they're listed. They're listed.
Oh, yeah. Well, that's good. If you dig down deep, you can find their name somewhere. But they really are. They did this because they believe in the importance of the question and volunteered their time. They provided a service.
And God bless all of them.
Yeah.
But the question I want to ask you is this. So you found out something very general that's interesting about the reliability of psychology findings, quote, on average. If you did it again with a different 100 articles, it'd be interesting. You might get 36% reliability or 48 or 18. Obviously, if you had an infinite budget and you could try to replicate some of the larger studies, you'd get a different result. But you also may have learned, I assume you learned something else that I didn't see in the Science article, which is there's certain stylized facts, and I'll choose behavioral economics because it's the interface between our two disciplines. So there's certain stylized facts that have emerged from lots and lots of experiments that people assume to be reliable. Just to take one example, that people feel differently about losses versus gains. Yeah. So that reaction to that is asymmetric. So there's a bunch of those findings, and I listed one earlier in psychology that when you hear the words old or senior or AARP, you start to move more slowly. So those are less confirmed, obviously, because they might be based on one study, one paper. Is there any pattern in the unreproduced studies that shouts out at you from the 100 replication attempts? Did it turn out that, well, the 60% that failed roughly, most of those were in such and such an area. I guess those are questionable. Did you learn anything qualitative that you can share?
Yeah, we did exploratory analysis of different characteristics of findings because it would be highly beneficial to be able to predict challenges for reproducibility. And that doesn't explain, but you can at least predict when they occur. So one that has generated the most discussion, at least within the field, is the fact that we were successfully reproduced findings in cognitive psychology, right? Looking at the basic operations of the mind, perception, memory, attention. We reproduced those effects at twice the rate as we reproduced social psychology effects, my discipline, right? Understanding ourselves, interactions with others, stereotyping beliefs about people. So why? The obvious question is why? Why is it that we observe twice the rate in cognitive than social? Is it that social is doing worse practices and so they're not? They're just not as reproducible?
It's obvious, Brian. Those are the less honest people. It's it's your field. You got to face it.
So there we go. So we've solved the problem.
Yeah.
It is possible that there's something about the research practices. It's possible there's something about the people. It's possible there's something about the kinds of things that are being studied.
Yeah, probably that.
One obvious thing at the latter end is that social psychology is investigating things about the social experience, about the context in which behavior occurs. And doing replications necessarily changes the context. So it's quite possible that the replications have much weaker evidence than the originals because they weren't sufficiently attentive or weren't able to address those shifts in context. And so it really is varying across different. So that's a possible explanation. A lot of people, especially those that are involved in social psychology research, will gravitate to that kind of possibility. Of course, we don't know if that's the explanation because other possibilities are also plausible. Another difference between social and cognitive psychology is that most or many cognitive psychology research applications use what are called within subject designs. Right? I am my own control because I'm in multiple conditions, multiple treatments of the experiment. Right? You flash me words on the left side of the screen, and then you flash me words on the right side of the screen, and you compare my responses between the two. That is a highly powered design because it reduces a lot of error. You don't have to compare me in one treatment condition to you in a different treatment condition.
For sure.
But social psychology tends to use more between subjects design. You can't, in the same experiment, easily increase my self-esteem and lower my self-esteem and have me feel like that makes any sense at all. And so we need to use more between subjects designs. And those tend to be lower powered. And so we may be seeing a consequence of some of the methodological differences between fields to produce that kind of.
So there's a group at Berkeley. It's the Berkeley Initiative for Transparency in the Social Sciences. And I was happy to see they recently launched the Lemur Rosenthal Prize prizes, plural, for open social science awards that honor research that's particularly transparent and open about reproducibility. Being an economist and a fan of Ed Leamer, I don't know Rosenthal, but I was happy to see this. And Leamer's essay on the launching of the prize is phenomenal. I recommend it to people. I'll put a link up to it. I noticed that you're on the executive committee of the Berkeley Initiative. What's going on? Why is this issue getting so much attention these days? 5 or 10 years ago, when you and I would grouse about this, complain, and be worried about it, people would say, yeah. And nobody would they just keep publishing. All of a sudden, social science, and I think science is next, social science is very self-aware. Social scientists are very self-aware of this issue. Why do you think it's now?
Yeah, it is a curious phenomenon because methodologists have been talking about this for 40, 50 years, writing papers now and again. And, the same issues have been coming up over and over again. Bob Rosenthal, the other part of the prize, is coined the term file drawer effect. And it was talking about how lots of the research disappears into the file drawer, and that's creating a bias, this publication bias. And talked about all these issues in the 1970s. So why is it now? Well, there's easy ways to identify reasons within particular fields. But the weird thing is that it's happening across all fields. And it has extended to the life sciences and physical sciences dramatically so. And so I think what has changed, and I can't really say this is the cause, but what is different this time and how it has become such a discussion is that issues of reproducibility have come up in many different places, sort of all at the same time. And that has produced a collective discussion that everyone is involved in. It's not just methodologists. It's not just practicing researchers. It's also funders. It's also the federal governments are paying attention to this issue. And it's also technology groups and organizations that are trying to do things to address it. And so it is as if there was some tipping point that just turned this into, we got to deal with this. No more ignoring it. All of this is sort of collectively moving us to action. And we talk about particular events in different fields, but I think a large part, what is common across those fields, is that it's become a lot easier to examine the current published literature. The internet has provided some value for scientists, and that is doing large-scale search and discovery of the credibility of evidence in the published literature itself. And so a lot of the interesting studies that were done over the last 5 or 10 years really look at publication practices, published evidence, and can make more general conclusions because of that about the potential challenges.
How big a problem is reproducibility in the physical sciences? I used to think this was my problem, meaning in economics. And I thought, hey, psychology's got some issues. And sure enough, of course, they do. I was talking to an astronomer friend of mine, and he was bemoaning how dishonest and not dishonest, but biased the results in his field are. And you think, well, astronomy, isn't it just black and white there? And the answer is, of course, it's not. Right. There's the way that the data is filtered through. It's not just like it's not counting. You're not just saying how many apples are there in this bushel. It's really inevitably there are too many decisions to be made about what gets included in the data, how the data are measured, and what gets into the data set, and then how it's manipulated in every field. So do you see this as going to be as being a wake-up call for science generally?
Yeah, it is pervasive across the sciences, and I think for two particular reasons. One is that the incentive challenges are the same across the scientists. Practicing scientists are competing very hard to get a very limited number of jobs and then advance through the career ladder in those jobs. It doesn't matter if you're a physicist, a chemist, economist, a psychologist, or anybody else. Those pressures are there, and they all have a shared publication practice pipeline. There's some variations across disciplines and how that operates in the particulars, but there is the same kind of limiting sieve that people have to get through. The second factor is that everybody is working on problems that they don't really understand the answers to yet. That's why they're working on them. right? So it isn't that physicists keep going back to their office and saying, well, okay, I'm going to drop this feather and this bowling ball one more time and see which one lands first. And do we use a vacuum or do we not? Oh my gosh, we discovered friction, whatever it is. They're not doing that. They're on problems where there is a lot of choice, there is a lot of uncertainty, there is a lot of things that are not understood about the phenomenon. And so all of that subjectivity, flexibility, decisions about what to report and not to report, that happens everywhere. There's only that very limited set that we can point to where there is a strong confirmation test that's happening, where there's a very strong model and very strong expectations of what ought to occur or ought not to occur that can test against that model, right? High energy particle physics spent billions of dollars on building tools in order to test some very important principles of how what particles exist or not. And the Higgs boson experiments were critical experiments. They built replication into it. They had very, very high standards of evidence, and it was testing against a very strong prediction. Right? It was model science, and it cost billions and billions of dollars. That's not how all physics works. So these challenges aren't happening just in the domains that we exist in, which don't yet have strong models, but even in places where models are maturing to a good.
So what's next? What's going to be the next big project at the Center for Open Science?
So relating to the Reproducibility Project and our discussion we just had is that we need to have more information about reproducibility across domains and even deeper within domains. So this project, even though it was a very big project, was just one study. It isn't definitive. And there are many things that might be changed, be improved, be deepened in trying to understand reproducibility. So we have an active project that's modeled on the Reproducibility Project in psychology in cancer biology. So we're doing 50 replications of prominent results in that field, and that's ongoing now. And then we've been talking to groups in other disciplines for doing similar kinds of projects in their disciplines. And we're not experts in all of these different disciplines. We have more of the how do you run a project like this, how administrative expertise, and then the just general expertise of reproducibility, regardless of the content domain. So we're trying to help these different groups sort of get these kinds of projects going. There is a team doing one in behavioral economics. We're not directly involved in that one, but I'm excited to see what they find.
Yeah, the related area in economics is the that needs to be looked at is some of the experimental results in development. Yeah. The deworming work is under some serious issues of reproducibility, and also the decline effect is there. We see the original study on deworming had these wonderful effects. Now it doesn't appear that they may not be as large or they may not exist at all. So seems to be very, very important. Before we close, I forgot to ask you, I wanted to hear you talk about the reaction of the authors whose studies have been declared unconfirmed or unreproduced. I suppose it's possible that some of them had more than one study in 2008 in one of those three journals. Did anybody have multiple failures or successes? And in general, have they screamed?
On the first question, I think there was only one or two people that had more than one study in the sample, and I don't know what the outcomes were for multiple ones for a single person. But in terms of the reactions of the original authors, they've by and large been very positive, and that doesn't mean that they haven't been skeptical, but by and large they've been positive in engaging with the project. That it isn't just that people doing the reproducibility project that care about reproducibility. Most researchers care about it. And so there was a lot of good collegial interaction between original authors and the replication teams in doing good faith tests. And of course, they have lots of reasons to be skeptical and concerned because they do have skin in the game in this. Because in the current culture of science, people do feel some degree of ownership and investment in the results that have come out of their research. And so the fact that they were by and large, positively engaged was just a very encouraging to me about the state of science and the potential for addressing these challenges.
I guess they'd be less collegial if the journals withdrew the articles exposed. Special issue. We have to now. The following articles are no longer going to be in the online archive because they've been found to be unreproducible.
Right, and that would not have been, and of course that would have been way beyond the replication is just one attempt, and it could have messed up. We don't know. And I should note that it hasn't been that's uniformly been positive. There are there were challenging interactions in a number of cases. There were people who said, "Well, I don't think this was done to the standards that I would have wanted it to be done in terms of the replication of their study." And we're trying to surface all of that and give original authors an opportunity to talk about what their experience and expectations and how they revise or not their beliefs about the research that they had done based on the replications. Because that's really should be just part of the conversation. Replication is essential, and original authors have a perspective and often the most expertise in the particular thing that they were studying. And so you have to have that be part of the conversation of when a replication occurs and turn that conversation into one of puzzling over how can we get it right. It isn't a contest to see who is right. It's how can we work collectively to get it right in order to have a strong, credible base of knowledge that we can all be confident in and use to solve the social problems in the world.
My guest today has been Brian Nosek. I appreciate Brian's fighting through a cold and some of the vicissitudes of Skype on this conversation. He is a professor of psychology at the University of Virginia, co-founder and executive director of the Center for Open Science. Brian, thanks for being part of EconTalk.
Thanks for having me again, Russ.
This is EconTalk, part of the Library of Economics and Liberty. For more EconTalk, go to econtalk.org, where you can also comment on today's podcast and find links and readings related to today's conversation. The sound engineer for EconTalk is Rich Goyette. I'm your host, Russ Roberts. Thanks for listening. Talk to you on Monday.